So, like I said, if you wanted to try this first example, you were more than welcome to. I don't know how many of you did, but this is just, and maybe we clearly needed this. This is just a bit of a reminder of geometric sequences and the way these questions can be asked. If you look through past papers, and we are going to do a lesson with some like past paper type questions, if you look through those past papers, geometric sequences, it's tested in many different ways. But one of the ways we will always test sequences and series is through a question like this, where we give you a variable and ask you to solve for a variable. Now, we've done this with quadratic, we've done this with linear, and I want to have a look at one with geometric before we move on to arithmetic sum formula, just because it's always good to know how to work algebra into any topic that we do. Algebra, I think I've said this before, algebra comes up everywhere. In any section in maths, you're going to have to deal with algebra. So it's always good to just practice that and know how to deal with it. Right. Oh, English. That's right. So Toriso has already told us that a geometric sequence has a constant ratio. Now, guys, I've said this to you before. Once you know what the defining characteristic is of your pattern or of your sequence that you're working with, it allows you to answer these types of questions where you're solving for unknowns. If you don't know what defines your sequence, it becomes very hard to figure out what sort of equation you should be setting up, how you should be using the values of your sequence, etc. So now that we know that your constant ratio is found by taking T2 divided by T1. And that would be exactly the same as having T3 over T2, exactly the same as T4 over T3, and so we could keep going. As long as you are taking consecutive terms and finding the ratio between the second and the first, you are able to find your R value. And just in case we've forgotten our R value, remember this is Tn is equal to A times R to the power n minus 1. That is our geometric sequence or general term. Okay, so we've got some information here. It says x plus 1, x minus 1, and 2x minus 5 are the first three terms of a geometric sequence. And we have to do two things. We want to find the value of x, and we want to determine the possible sequences. Now, importantly here, it almost gives you a little hint of what's going to happen. The question specifically says sequences. So there's going to be two options. So that should be in the back of our mind as we start to do this question, and that I should be getting two possible values for x, so that I end up with, or at least two possible values for x, so that I end up with these sequences, these options for the sequence. Alrighty. So based on what we know about geometric sequences, we can use that knowledge to answer this question. So we know that T2, and just remember this is term 1, term 2, term 3. T2, which is x minus 1, divided by term 1, which is x plus 1, is exactly the same as term 3, which is 2x minus 5, divided by term 2, which is x minus 1. That is all true because of what our constant ratio is. So we have used that defining characteristic for the sequence, and we have now set up an equation that allows us to solve for x. And hopefully you remember, if you were with me for the quadratic sequences and the arithmetic sequences, we used the same logic. When we had a quadratic sequence where we had an unknown like a p or an x or some variable, we used the fact that we knew the second difference was constant. When we were looking at the arithmetic sequences and we were having to find an unknown variable, we used the fact that the first difference was constant. We have to do that when we are looking for an unknown. Alrighty, guys, so now that we have that, we now need to solve this. Now there's lots of different ways you can go about this. The basic sort of idea is that you're finding an LCD. But because there's one term on the left and one term on the right, an easy way to just deal with these fractions is to actually just cross multiply. So essentially taking the denominators and multiplying them by the diagonal or opposite numerators. That cross multiplication is essentially finding an LCD. So if you would prefer to go the LCD route and go and multiply the fractions accordingly, that's absolutely fine. But the cross multiplication is doing that. We're just sort of shortcutting the process. So if we go ahead and cross multiply here, we are going to see that we end up with x minus 1 times x minus 1 is equal to x plus 1 times 2x minus 5. So we've cross multiplied, we've now gotten rid of those fractions, and now we're able to solve for x. Because what we can see is that we can distribute both sides, so x squared minus 2x plus 1 on the left, and 2x squared minus 3x, minus 5 on the right. And we now have an equation that we can solve. Just remember, as well, grade 12s, whenever you have a squared, so an x squared, a p squared, or whatever squared, we have to be thinking about our quadratic equations. And our quadratic equations are the one where we make one side equal to 0, and we factorize in order to get essentially factors that we can make equal to 0 and solve like that. So what I want you guys to do is I want you to finish solving this equation for me. So I've told you it's going to be quadratic. The hint is make one side equal to 0. Let's see what values for x we get. So I'm going to give you like 2 or 3 minutes. Let's see what we get. And again, this is bringing in algebra. So in matric, you will not touch quadratic equations again. We don't do an equation section in algebra again in matric. You do it in grade 11 and grade 10, but we don't do it again in matric. So it's important to be revising this up, as I always say. And quadratic equations comes up here in sequences and series, functions, analytical, it comes up everywhere. So it's important to be able to do this stuff. Marisol on it. Okay, so Marisol, if you want to go a step further and figure out what the possible sequences could be now that you've got x values, you're more than welcome to. If you're not 100% sure, that's fine, you can wait, but I like where we're at right now. Guys doing nicely. Keep it up. I'm going to give you another minute. Nice, Tanda. Hey guys, let's have a look. Okay, so whenever you have a quadratic, actually generally speaking, when you've got equations, if you are stumped of what to do, a good bet will be to make one side equal to 0. You can move terms as you go along if you need to, but if you are stumped, a good bet is to make one side equal to 0. So that's what we're going to do. It really makes no difference which side is equal to 0, but essentially we now need to organize and group together our like terms. So I'm going to put everything on the right. If you put everything on the left, that's also fine. But if I bring this x squared over, it becomes minus x squared. So this is then just x squared. Bring the 2x over, becomes plus 2x, so it becomes minus x. Bring the positive 1 over, it becomes minus 1. So it's x squared minus x minus 6. Now, grade 12s, if you don't feel super comfortable with factorization, you are welcome to just use the quadratic formula. We spoke about the need to be on the Google Classroom on Monday, but I would really recommend you get yourself on the Google Classroom. What I've done for you guys is I've sort of taken the matric formula sheet and I've broken it down into each of the topics that you use those formulas for. And on your formula sheet is your quadratic equation. So, or your formula, whatever you want to call it. So if you're more comfortable with that, go for it. This is quite an easy quadratic to factorize. So this is x minus 3, x plus 2. And so we know that x is either equal to 3 or x is equal to -2. Just a little side note here, depending on how you choose to factorize, you have to show, if you choose to factorize without the formula, you have to show the brackets. If you don't, you will lose a mark. If you are not going to do that, you have to then show the substitution into the quadratic formula. So those are two things you have to show in finals in order to get marks. Hear my mouth? Have to show them. Either the factorized the brackets, so the factorized products, or you have to show the substitution into your formula. If you don't do that and you go straight from your quadratic to your answers, you will lose a mark. Okay, so don't lose marks unnecessarily. Please show either your brackets or your substitution. From there on, you can just go straight to the answer, that's fine, but you have to show those things. Okay, once we've got that, we can now go work out our sequences. So we've got two x values here that we need to be mindful of. So if we go with the x value of 3, remember all we're going to do is we're going to substitute back into the original expressions. Our sequence would be 4, because 3 plus 1 is 4, 3 minus 1 is 2, 2 times 3 is 6, minus 5 is 1. That would be the first potential sequence that I have. It is geometric because each time I'm dividing by 2, so my constant ratio is a half. If I go and have a look at my second potential sequence, again, just sub it back in. Minus 2 plus 1 is -1. Minus 2 minus 1 is -3. Minus 2 times 2 is -4. Minus 5 is -9. Again, it is quadratic. Each time you are multiplying by 3. So your common ratio is 3. So those are the two potential sequences you can get based on this original algebraic geometric sequence that you were given. All right, so whenever you are working with an algebraic situation, so when I say algebraic, I mean they give you a sequence that has x's or some sort of variable in it, you need to go back and you need to think about, I'm just going to make this a touch smaller, what are the defining characteristics of the sequence you're working with? Because it was geometric in this case, we worked with the fact that we know there's a constant ratio. So knowing your characteristics to be able to solve for x is vital. Okay, so I'm just going to leave that there in case you want to take a screenshot of that example. But let's now start jumping into some series. Okay, so we've been doing sequences the whole time. We're now going to have a look at series. Right, so as we get into this, sequences and series are not the same thing. A sequence is different to a series, and whilst it is quite obvious when it's given to you, we should understand what the difference is. So does anyone know, or can anyone tell me what the difference between a sequence and a series is? You're welcome to unmute yourself if you want. What's the difference between the two? We're having a slow Wednesday, grade 12s. Morgan, nice. Okay, so Morgan said a series is formed like a sum. Exactly. And that's almost basically what a series is. A series is a sum, is the sum of terms in a sequence. Okay, so if, for example, we looked at this geometric sequence that we got here, the geometric series would be 4 plus 2 plus 1, etc., etc., etc. A sequence, on the other hand, is just the list of numbers. So it's the list of terms that we have. So what we wrote down here is a sequence. 4, semicolon, 2, semicolon, 1, etc., etc. That's the difference at the end of the day. Nothing like super stressful, nothing that is overcomplicated. A sequence is the list of terms, whereas a series is now the sum of a certain number of terms in that series or in that sequence. Okay, so when we start to talk about series, we're now going to introduce new formulas because now we're needing to add terms together. And obviously you could add like the first 5, 10 terms, but if I asked you to add 35 terms, you don't want to sit there and have to work out all your terms of your sequence to 35. We want a nice easy formula that allows us to do that. And so today what we're going to have a look at is our arithmetic series. So basically adding together terms of an arithmetic or linear sequence. And that formula is S of n is equal to n over 2, open bracket, 2a plus n minus 1 times d. Now this is on your formula sheet. You don't have to learn this off by heart. And again, that formula sheet is on the Google Classroom with a sort of detailed breakdown of each section. But this is the formula that's really important for sort of today and arithmetic series. So S of n, unlike T of n, remember T of n was the term of value. S of n is the sum of however many terms you're working with. So if I said S of 8, what I'm saying is the sum of the first 8 terms. If it was S of 20, the sum of the first 20 terms, etc., etc., etc. This is arithmetic, guys. So the d in our formula is still the constant difference. I will just write it here in case. So this d is still our constant difference. And this a is still our first term. We know that n, so both of these n's, they represent the same thing, will represent the position of your term. And like I say, S of n is the sum of however many terms. So we need to be able to use this formula as we look at arithmetic series. So let's have a look at this first question. Nice and easy to start us off, but let's have a see. Determine the sum of the first 12 terms, and we could put this in the notation S12 of the arithmetic series 2, 5, 8, etc., etc. Now we know it's a series because it's plus. It's 2 plus 5 plus 8 plus etc., etc. And I want to know up to the 12th term. I don't know what that 12th term is, but I want to know what the sum is all the way up to the 12th term. Now, I don't actually need to know what the 12th term is. If you go back to your formula, the only two important things that you need to know here are the constant difference, as well as the first term. We know what the first term is, so that's not a problem. The only thing we still need to work out is our constant difference. And I've said this to you before, the first thing that you always do when you are given a formula or any sort of sequence rather, is you work out what your differences are, or what your second difference is, or what your constant ratio is. That is the first thing that you do, because all of these formulas that we use rely on those bits of information. So if we go to the series that we have here, we can see that each time we are adding 3 to get the next term. And so that implies for me that my constant difference is 3. And now that I know that, all I do is I substitute into my formula in order to find the sum. So the sum of the first 12 terms is equal to n. I'm looking for the sum of 12. So n is 12 terms divided by 2. Open bracket 2a, a is 2 because that's my first term of my series, plus n, which we know is 12, minus 1 times my difference, which is 3. So n is the number of terms you are adding together, a the first term, d the constant difference. And because you found all of that, or you've worked it out, or whatever you've done, you got it. And then you just put that into your calculator. So I'll give you guys a second to do that. You can pop it on the chat, or you're welcome to unmute yourself. You can tell me what the sum of these first 12 terms are of this arithmetic series. Nice, guys. Loving the answers coming through. Amazing stuff. Awesome. So exactly as you guys have said, it's 222. So this is why the formula is so nice. You don't need to know all the value of those 12 terms. You just need to know the first and the constant difference. Now, if you are interested in where this formula comes from, there is a whole derivation of it and why it is what it is. You can Google it. Your textbook probably has it. It's not something you need to know. It's not something we test you on. So if it's something that interests you, you are more than welcome to go and Google it. But it's not something that we test you on, so I'm not going to really dwell on it. But there is a reason why the formula looks the way it does, and you are welcome to go and find out. All right, guys, so let's have a look at a second example here. Sorry, let me just wait here in case you want to screenshot this. Let's do that. And then I'll move on to example 2. Okay. So if we have a look at example 2, determine the sum of the first 20 terms of the arithmetic series -1, 3, 7. So I'm not going to stress about the formula just yet. All I'm going to do is I'm going to figure out what I'm adding or subtracting here. So quickly on the chat, what am I adding or what am I subtracting in this arithmetic series? What is my constant difference? Nice, thank you. Okay, guys, exactly. We're adding 4 each time. -1 plus 4 is 3, 3 plus 4 is 7, and so we would keep going. Now I want the first 20 terms. So I'm not going to write my sequence out to 20 terms. I'm just going to use my formula. Now again, grade 12s, this is on the formula sheet. You don't have to keep writing down the formula. I'm going to always write it down just so that we can sort of start associating this formula with arithmetic series, but you don't have to. So S of n is equal to n over 2, blah, blah, blah. I'm not going to say it all again. Tedious to hear my voice like that. Okay, so it's on the formula sheet, use it. You don't have to write down the formula, you can just go straight into the substitution, which is what we're now going to do. So we want the sum of the first 20, so n is equal to 20 over 2. My a term, remember, is the first term of my series, so that's -1, plus 20 minus 1, and we've just worked out that our constant difference is 4. Once you have it, you chuck it in your calculator, and you get what the sum is. So again, I'll wait for you guys. Tell me what the sum of the series is. Nice, guys. Amazing. Okay, exactly. The sum is 740. Right, so 740 is the sum of the series. And again, it's just substituting onto your calculator. All right, nothing too tricky. Oh, sorry, child. Alrighty, so take your screenshots and then you're going to try one by yourself. I'll explain it now, but remember, these are the questions where I give you one that's a little bit easier, one that's a little bit harder. You decide how you're feeling about it. If you would like to try the harder one, do it. If you would like the easier one, do it. I'm going to do answers for both, so you don't have to stress. Right, but here are your two options. So in both cases, you're just finding the sum. In the easy one, your series is 5 plus 8 plus 11 to 20 terms. In the medium one, your series is negative 14, negative 9, negative 4, all the way to 100 terms. So give it a try. I'm going to give you like 5 minutes and then we will see what you got. I don't think you need 5 minutes, but I will give you some time. I'll check in a second and then we can decide if you are ready. Remember, guys, if you've got questions, you're welcome to unmute yourself or you're welcome to put them in the chat. I will help you. Awesome that some of you are doing both. That is amazing. Okay, it looks like I'm getting a few answers. I'm going to give you 1 more minute to wrap up and then we'll have a look. Okay, guys, there was a question just about quizzes. So remember last week we didn't do a quiz just because first week easing into it, getting the hang of things. There is a quiz today, so that can be found on the Google Classroom. I will get those details again and share them with you again to join the Google Classroom. For this week, I will send you the link to the quiz as well because I get that not everyone has had the time or has been able to yet join the Google Classroom, but it will be released there. But from next week, that's where you access it. So I'll send the link this week, but as of next week, you need to be on the Classroom to access it. And like I said, that's also where I put a whole bunch of resources in terms of past papers, the formula sheets as we start to go on in the year, like I'll put like practice stuff up, just that you have these resources as you prep in for June exams, for mock exams, and for finals. Right, lovely, guys. Let's have a look. Okay, so if you did question 1, here you go. The sum of the first 20 terms here was 670. Your first difference or your constant difference is 3. And so you just sub it in your formula and off you go. For the second one, your constant difference here, you just needed to be careful. You were going from -14 to -9. So you were actually getting more positive, which meant you were adding 5 each time. That meant that your sum was 23,350 of the first 100 terms. Looks like those of you who tried both got both, which is awesome. Looks like those of you who tried one got the one that you tried, which is awesome. So really, really well done, grade 12s. I'm just going to wait there in case you want to screenshot this, but otherwise I'm going to shimmy on over to example 3 here. Okay, let's see. So example 3, we have got the arithmetic series -3, -5, -7, all the way up to -47. So what I want you guys to notice here is that if I scroll back up to the other questions, all of them have just been like a dot, dot, dot at the end, telling me that I can keep going to infinity. This one, however, is a bit different. This one, however, has got a final or an end term. So over here, this -47 is the last term of the series, which means that it's what we call a finite series. So infinite goes on forever, finite, it stops. So this series stops at the term -47. We don't know which term that is. It could be the 10th, it could be the 10 millionth, we don't know, but we know it stops. And that's really important to know because now when we look at the first question, it is asking us to calculate the number of terms in the series. Now, guys, what's really important here is nowhere have they told us calculate the sum of, or the sum of these terms is whatever. There's no mention of sum just yet. And so because of that, we don't necessarily have to use our sum formula. If we did, we would have too many unknowns. Okay, we don't know what the sum is. We don't know what n is because that's what we've been asked to find here. We would have too many unknowns to solve this. What we need to remember, though, is there is a second formula that is associated with arithmetic sequences, and that is Tn is equal to a plus n minus 1 times d. And this formula is great because we have the value of the term. It's -47. We know what a is. It's -3. And it's very easy for us to work out what the constant difference is. We have then 3 of our 4 variables and we can solve for n. So don't forget about your Tn formula. It's still there, it's still useful. Every now and then we do need to actually bring it into play. Right, so if we have a look, like I say, we know what Tn is because the term value that we're working towards to figure out how many terms are in the sequence is at -47. We know what a is, it's -3 plus n minus 1, and we just have to work out what the difference is. So if we have a look at our sequence here, we can see that each time I am subtracting 2 to get from one term to the next, which means that my constant difference here is -2. And once you have all of that, you can now solve for n. How you choose to do this, guys, it's up to you. Some people like to start moving terms immediately. Some people like to simplify, whatever. I'm immediately going to bring this -3 over to make it +3. So that would be -44 is equal to, and if we distribute that -2n, we would have -2n plus 2. Again, I'm going to bring that constant term over, so it becomes -2, giving me -46 on the left, is equal to -2n. And obviously I'm solving for n, so I'll divide both sides by -2, which gives me 23 is equal to n. And so what I now know is that in the series that I'm working with, I have got 23 terms. Okay, that 23rd and final term is the value -47, and I now know which position it sits in. Now, all of this was really useful for me because now you can see in the second question, it says determine the sum of the series. I would not be able to do question B if I didn't know how many terms were in my series. So now that I know that, I can use my formula. So S of 23 terms is equal to 23 over 2, open bracket, blah, blah, blah. I'm not going to say it all. Okay, and then we just sub it into our formula. That's it. No stress, no issues. I forgot to subtract the -3. I assume you mean right at the start. And correct me if I'm wrong. So there was just a question of, or a statement of, okay, Mitchell, cool. So yeah, I just did it right at the start. You don't have to. It's completely up to you. Right, guys, let's chuck this into our calculator. Tell me what sum you get when you are summing the 23 terms. Very so nice. -573, 75. Now, guys, this makes sense. You are adding a whole bunch of negatives, right? So you're just getting more and more negative the more negatives you add on. So it makes sense that my sum is going to be a big negative value. Right, I'm going to wait and take you. That's English today. Oh my gosh. I'm going to wait. If you would like to take a screenshot, you can go for it. Could we use sum of n is equal to n over 2 a plus tn? So just be careful there with that formula. You're missing the 2 to the coefficient of a. Like I said, there is a reason why all of these things exist, but you do need to have that 2 in front of your a value, because you are essentially using the tn, but, oh, hang on, am I just losing my mind? Are you, sorry, Machika, are you saying you want to say n over 2 and then times first term plus the last term? Is that what you mean by that formula? Is that tn representing the last term? Oh, okay, sorry. That was my confusion. I do apologize. You are welcome to use that. It's not a formula we give on the formula sheet, so it's not one that I really use often, but if you're comfortable with it, absolutely. No problem. So guys, there is a slightly different formula if you know the first and the last term, and you don't have to use the whole long formula. It's n over 2 and then first term plus last term. You are welcome to use it. Like I say, it's not on the formula sheet, so it's not one that we often use, but if it's something that you've been taught and something you're comfortable with, 100%, no problems whatsoever. Alrighty, let's have a look at our next example. So example 4 says calculate the sum of the following finite series. So again, finite, it ends, it's got a final term. We know that that last term there is 111. In this one, I will actually show you both formulas just for interest sake. And like I say, it's up to you. I personally don't use it just because it's not on the formula sheet. And so I don't want to then use the formula that I maybe write down wrong. It's not a hard formula, so really completely up to you. So guys, the first thing that we need to do is we need to figure out how many terms are we adding together. So we first have to go to our Tn formula. Right, if we go and have a look, our constant difference is 2. And so that will be our D value, which means that 111 is equal to 3 plus n minus 1 times 2. Because remember, we're solving for n to figure out how many terms we need to add together. So again, I'm going to start by subtracting 3 on both sides. So 111 minus 3, 108, is equal to 2n minus 2. Sorry, those are weird looking 2. I'm going to add 2 on both sides. 110 is equal to 2n. Divide by 2 on both sides. N is equal to 55. So there are 55 terms I have to add together. So if we go with our two formulas that we could potentially use, I'm going to use the formula on the formula sheet first. S of n is equal to, or S of 55, now that we know that, is equal to 55 over 2, blah, blah, blah. Chuck it into a formula, and you get that the sum is 3,135. Makes sense that it's quite a big sum. All of them are positive. We're adding 55 terms, which is a lot of terms to add. So it does make sense that our sum is quite high. All right. If, however, you would like to experience or you would like to use a different formula, again, there's nothing wrong with it. I just choose not to use it because it's not on the formula sheet. And if we then write it down wrong or memorize it incorrectly, it is a problem, but you get the same answer. So the formula that you can use as well, only if you know the first and the last terms that you're adding together, is that S of n is equal to n over 2 times a, which remember is your first term, plus I say L, which is your last term. So first term, last term, and then you sub in. So sum of 55 terms is equal to 55 over 2, 3 plus 111, which still gives you 3,135. So it is a much easier formula, and that's why I'm saying absolutely use it. If you can memorize that and use it 100%, but you don't have to. It's completely up to you, whatever works best. Okay, guys, any questions? Let's take our screenshots in the meantime, though. Oh, sorry. Okay, now there was a U try coming next, but I want to do one more type of question just because then we sort of cover our bases in terms of arithmetic sum series or arithmetic series. And then obviously you do have the quiz to practice it as well. Right, so I'm going to jump to example 5 here. And this question is a little bit different to what we've been having a look at. This question now says, how many terms of the arithmetic series 8 plus 13 plus 18 plus blah, 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 will add up to 1,700. So the question is essentially asking me, how many terms do I need to add in order to get this very specific sum? So what's really important here is that we take note of and we realize that this 1,700 is the value of Sn. They have given me the sum. They are asking me how many terms, so they are asking me for n. So when you get questions like this, break it down like that and figure out what it is you know, what it is you're looking for. All right, so first thing that we always do is figure out what we're adding or subtracting. In this case, I am adding 5 each. Sorry, everyone, who knows what I just did there? We're adding 5 each time, so that will be my constant difference. And now I can go and use my formula. Now, in this case, you can't use this a plus L formula because you don't know what the last term is. We have to use the formula on the formula sheet. If we go and do that, like I said, I'm just going to keep writing it down so that somewhere in the back of your head, it's like ingrained in your brain. And we go sub in what we know. So we know the sum, 1,700. N is what we are looking for. We know the first term is 8. And we know our constant difference is 5. And so what's really, really important here, guys, is your goal at the end of all of this is to solve for n. And so this now takes us back to our algebraic equations. We now somehow need to isolate n in order to get its value. How you choose to do this is completely up to you. There are different ways to solve this just based on the operations you choose to do first. My personal preference, I don't want fractions. If I can get rid of the fraction, I'm going to get rid of the fraction straight off the bat, and then I don't have to worry about it. So the first thing I'm actually going to do here is I'm going to times both sides by 2. Because if I do that, I get rid of the fraction right in front, and it means that I don't have a fraction to deal with anymore. So that means I've got 3,400 is equal to n. Now I can simplify what's going on inside these square brackets. 2 times 8 is 16. If I distribute my 5 plus 5n minus 5. From there, I will now need to distribute the n. But before I do that, I am just going to simplify what's in my bracket because 16 minus 5 is 11. So I need to distribute n in order to get the quadratic formula or to get it into standard form. And so I've got 3,400 is equal to 5n squared plus 11n. Remember, standard form for your quadratic equation is ax squared plus bx plus c is equal to 0. So that's what we want to get it to. And so we're going to have to bring that 3,400 to the right. So 0 is equal to 5n squared plus 11n minus 3,400. And now we've got this quadratic equation we can go and solve. Now, I've said this to you before, if you can factorize that without the use of the quadratic formula, well done you. 3,400 is a massive number with a lot of factors. I'm not even going to try. I'm just going to sub it straight into my quadratic formula. So n is equal to minus b, so minus 11 plus or minus the square root of 11 squared minus 4 times 5 times negative 3,400 all over 2 times 5. So that's the beauty of the quadratic formula. No matter what quadratic equation you get, you can solve it. You just substitute it. And like I say, please do show the substitution. Right, guys, I'm going to give you a minute. Quickly substitute that in and give me the values of n that you end up getting. Okay, so we're subbing into our quadratic formula, and I want you to tell me your values of n. Nice, Joy. Okay, Joy has put a beautiful explanation there on the chat. So Siam Tanda and both Brooklyn, or rather, both Siam Tanda and Brooklyn said n equals 25, which is perfect. Remember, quadratic, you get two solutions, but as Joy has explained there, one of them is not applicable. So the two values of n you get is n equals 25 or n equals like negative something, negative 136 over 5, which is negative 27.2, as Joy said down the chat. This is not possible. So we put a line straight through it. And so now we know that if we add 25 terms of the series, we will get a sum of 1,700. Now, guys, as I've said before, check yourself. If you're not feeling sure, go check. Take this value of n that you have just determined and sub it into your original formula and make sure that the sum of 25 terms is 1,700. So there are ways to check yourself whenever you're using a formula and you're solving for a variable. There are ways to check yourself.